Welcome to Daily Papers, the podcast where we break down the latest and greatest research into bite-sized chunks.
Today we're talking about something I think we've all experienced when using AI chatbots. You ask it a simple question like, who is the current CEO of Twitter, and it confidently tells you the name of someone who left years ago. It doesn't even say, I think, or I'm not sure. It just gives you the wrong, outdated answer with complete conviction.
Exactly. And for a long time, the assumption has been that this is just a bug, an engineering flaw we need to iron out. But a new paper, The Geometry of Forgetting, suggests something much deeper is going on. It argues that this isn't a simple failure, but a fundamental part of how these models are structured.
The core problem they're tackling is that it's impossible for current systems to tell the difference between a fact that's correct, a fact that's outdated, and a fact the AI just completely made up. To the outside world, they all look the same.
But this paper found a way to look inside the model, into its internal thought process, or what researchers call its representations. And what they found is fascinating. They discovered that the outdatedness of a fact is encoded in a completely separate hidden dimension.
Okay, hidden dimension sounds very sci-fi. Let's break that down. The best way to think about it is with an analogy. Imagine the AI's brain is a three-dimensional room.
Right. Let's say one dimension, from floor to ceiling, represents correctness. The higher you go, the more correct the fact is. The second dimension, from the left wall to the right wall, represents confidence. The further to the right, the more confident the AI is in its answer.
But this paper found a way to look inside the model, into its internal thought process, or what researchers call its representations. And what they found is fascinating. They discovered that the outdatedness of a fact is encoded in a completely separate hidden dimension.
Okay, hidden dimension sounds very sci-fi. Let's break that down. The best way to think about it is with an analogy. Imagine the AI's brain is a three-dimensional room.
Right. Let's say one dimension, from floor to ceiling, represents correctness. The higher you go, the more correct the fact is. The second dimension, from the left wall to the right wall, represents confidence. The further to the right, the more confident the AI is in its answer.
Most of our tools for checking an AI's work are basically just looking at those two dimensions. Is the answer high up towards the correct ceiling? Is it far to the right in the confident zone? But this paper says there's a third dimension we've all been missing.
And that third dimension is temporal drift, a fancy term for whether a fact is up to date or outdated. This is the axis that runs from the back wall of the room to the front wall. A fact can be way up by the ceiling, meaning the AI thinks it's correct, and way over to the right wall, meaning it's super confident. But it can also be way at the front of the room, meaning it's completely out of date.
And because our existing tools can only see up-down and left-right, they are completely blind to this forward-backward dimension. The technical term the paper uses is geometrically orthogonal, which just means these three directions, correctness, confidence, and outdatedness, are totally independent of each other, like the three sides of a corner.
So how did they prove this hidden dimension even exists? They built a special tool called a linear probe. You can think of it as a super simple detector, like a stud finder for a wall, but this one is designed to find one specific signal, the signal for outdatedness.
And this little detector was incredibly good at its job. They measure this with a score called AUROC, where 0.5 is just random guessing, and 1.0 is perfect detection. Their probe scored between 0.83 and 0.95, which is fantastic. Meanwhile, all the other methods that just look at confidence or correctness were no better than a coin flip at spotting outdated facts.
Then they did a really clever experiment to prove the probe was reading the AI's internal knowledge and not just getting tricked by the question. They took two different AI models. Let's call them Model A, trained in 2022, and Model B, trained in 2024.
And they asked them both the exact same question about a fact that changed in 2023. For example, who is the coach of Paris Saint-Germain in 2024? The older model, Model A, would give an outdated answer. The newer model, Model B, would give the correct one.
And here's the kicker. When they used their outdatedness detector, it lit up like a Christmas tree for the old model but stayed completely silent for the new one, even though the question was identical. This proves the detector is looking at the model's internal state, its actual stored knowledge, and seeing that for Model A, that fact has drifted into the outdated zone.
So why does this all matter? It tells us that our current hallucination detectors are fundamentally flawed. They can't reliably catch an AI giving you old information because they aren't even looking in the right dimension.
And that's a huge deal for any serious application. If you're a doctor asking an AI about the latest medical guidelines or a lawyer looking up a recent legal precedent, getting an answer that's a year or two out of date could have massive consequences. The AI isn't really lying in the human sense. It's just telling you the truth as it learned it back when it was trained.
But the good news is that this paper points to a solution. We now know where to look. We can build new tools, new probes that are specifically designed to check this outdatedness axis. It's like we've finally been given a blueprint of the AI's internal filing system for time-sensitive information.
The paper also has one last interesting tidbit. They looked at two types of wrong answers: stale recall, which is remembering an old fact correctly, and confabulation, which is just making something up from scratch. And they found that inside the model, the mental processes for doing both are almost identical.
Which explains so much. It tells us why from the outside it's so hard to know if the AI is remembering something old or just inventing nonsense. Internally, the circuit that retrieves the information treats both tasks in a very similar way.
So, this paper gives us a whole new map for understanding how AIs forget. It shows that outdatedness isn't just a smudge on the glass, it's a completely separate axis in the geometry of the model's mind. And knowing that is the first step towards building AI we can actually trust to keep up with the times.